In December 2025, the Ministry of Electronics and Information Technology announced the launch of Dhruv 64, a fully indigenous microprocessor developed by the Center for Development of Advanced Computing (CDAC). The processor is projected as a critical milestone in India's effort to build a domestic semiconductor and processor ecosystem and reduce dependence on imported chip technologies. Background: India, the semiconductor challenge. India is one of the world's largest consumers of electronic devices and processors, yet it remains heavily dependent on foreign design chips and global supply chains. Microprocessors form the core of modern digital infrastructure, powering telecommunication, industrial automation, defense systems, automobiles, and consumer electronics. Dependence on imported processors exposes India to supply disruptions, export controls, and cybersecurity vulnerabilities. Recognizing the strategic vulnerability, the Government of India has consistently pushed about Dhruv 64. Dhruv 64 is a 64-bit dual-core general-purpose microprocessor developed by CDAC under Ministry of Electronics and Information Technology's Microprocessor Development Program. Operating at a clock speed of 1 GHz, it is designed to strike a balance between computational capability and energy efficiency. Unlike simple microcontrollers used for basic sensing tasks, Dhruv 64 is capable of running modern operating systems and handling more complex workloads. Its intended applications range from consumer electronics to industrial automation and embedded systems, where reliability and integration matter more than peak computing power. Technical significance of the processor. From a technological perspective, Dhruv 64 does not compete with high-end smartphone or laptop processors that feature multiple cores, advanced GPUs, and high clock speeds. Instead, it targets sectors such as telecommunication equipment, industrial controllers, routers, and automotive modules, where stable performance, long life cycle support, and secure architectures are crucial. Such sectors value hardware, software integration, and predictable behavior rather than raw speed. This makes Dhruv 64 relevant for strategic and infrastructure-related applications rather than mass consumer devices. Role of RISC-V and the DIR-V program. A key feature of Dhruv 64 is that it is based on the RISC-V instruction and instruction set architecture. RISC-V is an open source instruction set, meaning that its design rules are publicly available and can be used without paying licensing fees. This openness allows countries like India to design processors without dependence on proprietary architecture controlled by foreign companies. RISC-V is also modular, enabling designers to customize processors for specific tasks such as security, performance, or energy efficiency. Dhruv 64 is part of the Digital India RISC-V DIR-V program, which aims to develop a portfolio of indigenous processors for civilian, industrial, and strategic uses. Earlier processors under the ecosystem include Shakti, IIT Madras, Ajit, IIT Bombay, Vikram, ISRO, SCL, and Tejas processor developed by CDAC. Concerns and information gaps. Despite its strategic importance, Ministry of Electronics and Information Technology announcement leaves several critical questions unanswered. The government has not provided detailed performance benchmarks, memory architecture details, or power efficiency metrics, which are essential for industrial adoption. There is also limited clarity on fabrication details such as the manufacturing foundry process, node yields, and long-term reliability. Additionally, the term fully indigenous remains ambiguous, as it can refer to different aspects such as design, toolchain, fabrication, or ownership of intellectual property. The absence of a clear deployment roadmap of operating system support and government procurement plans may slow industry adoption in the short term. Way forward for India's chip ecosystem. Dhruv 64 must be viewed as a foundational step rather than a finished solution. Its success will depend on the creation of a supporting ecosystem that includes developer board, software tools, skilled manpower, and anchor government demand. Complementary initiatives such as Chips to Startup program, design linked incentive scheme, and the India Semiconductor mission are critical to building fabrication capacity.